Hello, everybody. Thank you very much. Arrivederci. All right. Who's currently running at work on Python 2.5? 2.6? 7? Oh, there's some overlap. Okay, so 2.7 is a fine thing. I am encouraging everyone to migrate to 2.7 as fast as possible. You know how Ubuntu has this notion of a long-term maintenance release, one that they're going to maintain for years? 2.7 is going to be ours. 2.6 is not getting any bug fixes. It's not getting any attention at all. Very quickly, the entire community is converging on 2.7. Wesley told us this morning that Google App Engine will soon support Python 2.7. And so it's where I recommend you ought to be, and where you can get so that you can play with Python's newer tools. I'll even show you some that are in 3.2, and if we have a little time, I'll show you something that's in 3.3. Who's running Python 3.3? All right, just a couple of you. We actually have a link for a daily build, and so you can pull down and be running with 3.3 every day if you'd like to live on the bleeding edge. So, what if you're not using Python 3.3 at work? Can you get the newer tools? And the answer is yes. Most of the things that I'm put into Python in the last few years, I go out and I put an equivalent recipe that runs on older versions of Python. So if you'd like to have an ordered dictionary and you're running Python 2.5, you can go out to the Python cookbook, pull down that recipe, and it will. I've designed them to where they are compliant with, they pass all of the tests in the later Pythons. So if you'd like to have an LRU cache and you don't have one, if you'd like to have a counter and you don't have one, go into the docs for the newer version of Python. There will be a link to the code that runs on old Pythons. So you can be running on a new Python even though you have an old one. Got the gist? All right. All of these tools can be yours. Okay. It is my aspiration to use Twitter for something good other than telling people where I'm currently standing at the moment or who I'm talking to. So if you subscribe to my Twitter feed, I promise not to spam you, and instead I am trying to, at least once a day, sometimes 2 or 3 times a day, tweet out Python tips as much as can be fit into 140 characters. It seems to be reasonably popular. So anyway, new Python tips. Ready to get the show rolling? All right. Collections counter. So collections counter was modeled, the way some of this design process works is the idea of something that's going to be generically useful enough to be collections. In collections is probably some technology has been invented before, and so the API design starts with taking a look at what has been done for the previous technology. So look at multisets in C++, bags in Smalltalk, and Objective-C, and a decision was made early on to not completely encapsulate this and lock it up and guarantee that you can only do increments and decrements. We left it wide open. What does that mean? We subclassed dic. So what is a counter? A counter is simply a dictionary that has this extra capability that you can that it has a default value of 0. So if you look up something in this dictionary and it's missing from the dictionary, it'll return a count of 0. So what can you store in the counter? You can store anything because it's a dictionary. So you can put junk in your counter and use it for things other than counting. You can also count with integers, including negative numbers, if negative numbers make sense in your application. You can count with decimals. You can count with fractions. It's just a dictionary. Quick, what can you put in it? Anything, because it's just a dictionary. Okay, good enough. It's amazing how many discussions I have around counters. Can I put, yes. Okay, all right. So it's a simple design. It started out close to being a 2-liner in Python. Class counter inherits from dic, find under missing, return 0. That was the beginning, and at that point you already have a usable counter. It's easy to use. It has an under missing method that returns 0. Who knew about the under missing method? I'm impressed because a shocking number of people who've been using Python for years, read the docs and whatnot, have no idea that there's an under missing method for dictionaries, and it's a fantastically capable tool. There's a lot of things you can do with it, and if you haven't used it before, I recommend that you play around with it a little bit. It is part of our core dictionary API now, and so lots of objects will support under missing. Like if you subclass an ordered dictionary, it'll support under missing. All right. And then I went one step further and said, well, if we look up an item in a dictionary and it says that its default value is 0, what is the count of the number of Raymonds in the counter? And the count is 0. Well, I'd like to be able to, if the get succeeds, I'd like to have a del succeed. So we built that out a little bit so that it's easy to delete. So you can write lines like this to do a tally, to increment the counter, and lines like this to delete something out of the counter, whether something is already in there or not. You don't have to take care of putting a value of 0. So this will never raise key error, and that will never raise key error. And that gives it a clean API. Seems simple enough? Let's push the design a little bit further. And let's show you how it's made. So if you're going to make your own, you would make a class counter, subclass dict, add a missing method that returns 0. So anytime someone does a lookup into this dictionary, if an item is missing, it is called and returns 0. Fair enough. And then del items matches. It just checks to see if the element's in the dictionary. It'll delete it. If it's not in the dictionary, it's already gone. Hey, this is kind of cool. We'll use super here. Is that good for anything? We'll see shortly. Things like this add fantastic superpowers to counter. Who's read the super considered super blog post? Oh, some of you have missed out. Who's heard of the super considered harmful blog post? Everybody. Those of you who've been lied to. You've been told this tool is off limits, that it's no good, that it's not good for anything. You don't know that it has superpowers. I recommend the super considered super blog post. It is a clear set of instructions on how to use super in a way that works every time and is really hard to emulate using any other programming technique. Okay, so I'll stop promising the future and back to the present. So here's how you instantiate a counter. I can count my x's and add 1 to it. That's the normal usage. I can count y and add 2 to it, so you don't have to count one at a time. Or I can set a value, which is kind of nice. If I had attempted to build some bag class where I overrode every accessor, it's easy to leave one of these out and say, people can only count one at a time, so you can set values here. So the output of that looks very much like a regular dictionary. Why does it look like a regular dictionary? Because it is. All right, what happens if I do a del W? Key error? No, because we have the dicta. Simple design. You happy with counter so far? Could we have called our design done? Absolutely. But maybe it needs some convenience methods because we think about what do people do with counters. That was not an excellent segue, was it? Oh, an example of using a counter. Let's say you have a results counter. You loop over your test. If the test passes, add 1 to succeeded. In either case, add 1 to attempted. So it's a very simple use of counter. It's a much cleaner looking code than the old style using get or having to build yourself a custom dict with under missing or using a default dictionary. Default dictionaries are very easy to use, but somehow it gives people mental conniptions as if they're using something really advanced. Just like, default dict, that's way more advanced than Lambda. And I think the problem is the factory function. So for some reason, people find it to be mind-blowing. But what I like about this code is I can show it to a non-programmer, manager, client, or whatnot, and it's very clear to them that it does exactly what it says. And that's the kind of Python we strive for, is the kind that matches the business description of the problem. All right. Another example of using counter before I got to the extra features. So open some text. The example I put in the docs was actually open hamlet.txt. So I had full text of Hamlet, opened it, lowercase it, split it, used words to split up all of the words in Hamlet, get rid of the punctuation, and feed that directly into counter. Oh, got this extra method over here because a very common use of counter is, well, you've counted things, what do you do with the count? Well, I'd like to know what the biggest counts are. So what this says right here is, take all of these words, count them up, give me the 50 most common, sorted most common to least common. So it's fantastic for word counts. I could have fed in all of the URLs out of my logs, so I do a quick scan of the resource that's being requested out of all of my logs, take that iterator, drop it right here where it said words, and what does this line of code now do? It doesn't do a word count, tells me the top 50 hits on my website, the most popular resources. Who thinks that's fantastic? Something they can use every day. A couple of you, not that common. You want extra features, don't you? Convenience method. So I added most common. It returns a sorted list of the n highest count. So you can say, give me the top 50, top 10. Or if you supply no argument, it will just sort them all. So it reduces to a simple one-liner, something that matches the English description. Give me the 50 most common words, 50 most common URLs, that sort of thing. That way we have a very clear correspondence between a simple English declaration of a problem task and the actual code. Nice correspondence. Now, elements. Those of you who've used bags before in another language, knows the way that they work is by put something in the bag, put another thing in the bag, put another thing in the bag. I should be able to pull those things back out of the bag. So if I put in 3 red marbles and 2 blue marbles, and I say iterate over this, it says, here, you've taken one red out, another red out, another red out, a blue, and a blue. And so that's what Elements does, is it lists out the contents individually after handling their multiplicity. So it doesn't hand you 1 red marble, it hands you all 3. So it works just like the bag design iterator over bags in Smalltalk. It differs from the built-in iter method for dicts, because remember, this is just a dict. So what's the dict going to return if you iterate over it? It'll return just the objects, its keys, unless you say, give me items, in which case it will give you the key value pairs. What are the key value pairs? The object and their multiplicity. You have, so if you iter over items of the counter I just mentioned, the first return will be red 3. There are 3 red marbles. The second return will be there is green 2. Elements, on the other hand, red, 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 green, green. Got the difference? Convenience method. So the idea in the API design is to anticipate, after we've made a counter, anticipate how people are going to use it, and then make sure that their use cases are supported. Yes, sir? It returns an iterator. I always try and return iterators when I can. The only time I return a list is if I already have to fill up memory. So in the case of a sort, sorted will return a list because it's already filled up memory. But other tools like enumerate will return an iterator because it can handle them one at a time. So it's kind of a design principle. Good question. Anything else exciting on this page? You guys are really bored by this, aren't you? You want to know.
Is there also
least common? A least common? So I thought about putting in a least common, and there's a way to already get to it, like you say most common without any arguments, and then strip off using slicing to pull off of the end, same way you would do with a regular list. So you already have a way to get to least common. But then I thought about the use cases, and least common is not something that people usually seek out. They are trying to find, it doesn't match what people are after. So I didn't build in that extra method. Could have. It doesn't occupy a whole lot of extra mental space. But, so the opposing forces are someone somewhere might want it for a reason I can't anticipate now, balanced with I'd like to keep the API compact, and I'd still like to be able to sell counters as it's basically a dictionary, and when you figure out you want the most common elements, I happen to have a convenience method in there for you. But if I hadn't, you could have made your own in a number of ways, like just taking the items and doing a sort on the items, pulling it out the old-fashioned way. All right. So we put in some counter mathematics. Because you got one counter, you got another counter. You might want to do counter-to-counter operations. So if I add 2 counters together, so I have one bucket with my 3 red marbles and 2 green marbles, and another bucket with 10 red marbles and 4 green marbles. I can add them, combine them together, and it will add their multiplicities together. Subtract is the more interesting one. We have 2 different kinds of counter math. We have the regular math. So I have 2 counters here. One that has 1A and 1B, 1A and 1C. I take the difference between those. The A's go to 0. C's, the default count for C is 0, so the C goes to -1, and the default count for B is 0, so 1 minus 0 is 1. Anybody surprised by that result? Really? Some of you would be surprised by the result if you have used bag objects in another language. Like, what is the meaning of a negative count? You can't have negative marbles. If I were to use multi-set math, my counters have no meanings for negative counts. When I was in first grade and they taught me to count, Negative 1's not on the list. So for some use cases, this is not the appropriate kind of subtraction. The kind that you might want, the kind that's typically defined for multisets, has a name. Who knows what the name is? There's a technical term. Uncle Donald Knuth, calls it saturating subtraction. And the idea is you're subtracting off marbles until you get to 0, at which point you've fully subtracted out all possible marbles and you stop there. So you go no lower than 0. So that same subtraction here would have actually gotten rid of the negative case. So when I do the, and I'm doing a comparison here. On this line, I'm showing how does this behave with regular sets. A regular set A and B minus the set A and C just leaves B. Nothing happens with C. So this is normal set math. This is how we do it with counters. It gets the same result. The idea is that sets that have a multiplicity of 1, regular sets, and counters, their subtraction behaves exactly the same. Do you see the course? Who learned a new link between counters and sets? There's a deep relationship and not a shallow relationship. That's why they're sometimes called multi-sets. Sets that have unique elements that are every element that's in the set has a count of at least 1 and that there are no negatives. Okay, so 2 kinds of math. And your new term for the day is saturating subtraction. It is used in many contexts, not just this one. So if you were doing some image processing and you were darkening a pixel and you want to darken it by 10 pixels, you're never going to go higher than 255 and never lower than 0. So you will have been said to have saturated the pixel. Who learned a new term? Should have been every hand because no one knew the term when I asked for it. Let's move on. Name tuples. Raymond, name tuples aren't new. Sure they are. How do I know they're new? Because when I go out to consult for companies and I look at their code bases, I see an underutilization of name tuples. They have not yet won the world. They should win the world. So name tuples work just like a regular tuple. How do we know that? Counters are just name tuples are just so they are just a tuple, or some of us say a tuple. And so it is a tuple subclass. So it behaves exactly like a tuple. Who knows how much overhead is associated with a name tuple? Let's say I go to my database, I do a fetch all, and it returns a list of 1,000,000 records, and each one of those records is a tuple. Now I go cast that. I take every one of those tuples and turn it into a name tuple. How much extra memory have I consumed? 0. Inside the tuple, there's a pointer to each element in the tuple, and then there's a pointer to what kind of thing it is. And the pointer normally, its type pointer usually points to tuple. But when you cast it, it'll just change that pointer, and it will point at the name tuple, the thing that knows the fields. Your space overhead is 0. Who likes free? Free is good. All right. It is my belief that the use of name tuples can profoundly improve your code base. It makes your code more self-documenting. Whenever you have an error message and the repr of the object shows up on the screen, it is self-explanatory. And more importantly, it lets you change the order of elements in the tuple without affecting all of your client code. Most people who manipulate tuples, where the first field is the last name, second one's the first name, next one's the age, next one is employee identifier number, they will end up with a lot of code that says, take T at 3, store it in this field, update T at 2, and that will permeate their entire code base, which is a real problem if later you go and insert a new field in position 0. You have to change all of your code. What are the odds that you're going to be able to do that reliably? Perhaps if you have a really smart editor, if it's all concentrated in one place, if you have extensive unit tests, and if you're very, very lucky, all of those things will allow you to change it. But if you're using a name tuple, you change the order, and you won't have to change any of the client code. Have I sold you? Okay. Doc test. There was a time when you ran doc test, and you went, I shouldn't have given away the answer. Did you guys read that slide already? No. All right, so you ran doc test. Print out the result, and it returns the tuple. And it returns the tuple 0, 7. Are you happy or are you sad? Sad that you can't understand the answer, but you should be happy because what it actually means, and it now says, it returns a name tuple. And the name tuple says, this is a test result. 0 failed and attempted 7. It was a good result. You're happier now. So the old doc test returned just a tuple. Lots of doc test was out for a long time. Lots of client code uses that tuple. So what happened when I introduced a name tuple? Did I break any of the client code? Nope. It's just a tuple subclass. This thing, you can still say, take the result, assign it to t. T at 0 will be 0. T at 7, 2, or t at 1 will be 7. I could run list of the tuple, and it would give me the list 0, 7. I could feed it into something accepts an iterable. I could feed it into set just to see if these two are the same. In other words, what you could do after this conference is go back to your code base, go through every piece of code that returns a tuple, where the different fields have different meaning, turn it into name tuple, and your space overhead will be 0. Your readability will go up. You'll get beautiful reppers like this. It will cost you nothing. Who likes free? All right, have I sold you now? Okay, but what was the promise of this talk? Was I just going to sell you on a new tool? No. I'm going to show you how to make it, and then once we know how to make it, we're going to push it to the outer limits and say, what can be done with one of these? Let's go have some fun with it. All right, so simple implementation. Let's say you're making your own test results. You say class test results, inherit some tuple. At that point, you could say, I'm already done, and you will not have damaged your code in any way because it still behaves just like a tuple. We know that because it inherited from tuple. You guys seeing a theme of how I designed some of the collections? All right. So now we give it a nice doc string, which is great because the first time someone types in test results, a tooltip will pop up on their screen. They're using one of the more advanced editors like most of you are. Empty slots. What does that do for us? That prevents the formation of an instance dictionary, and it's why name tuples have 0 overhead. We learned something new. Fantastic. Now, name tuples know their own field names. Why would I put this in here? Make the object introspectable. So you can take a name tuple, ask it what its field names are. All right, it has a new method, so you can pass in failed and attempted. It has a nice repper. It knows its class name. Who knows why I didn't, right here, why I didn't put test result? Why did I use self.class.name? Change it. Do you also have a time machine? Because that's tomorrow's lesson. Tomorrow I talk on the art of subclassing. And the art of subclassing says we will design our classes to make it nice for subclasses in the future. So a subclass of test results comes along that says my combined test results, my validated test results, my successful test results. If that's a subclass of test results, its name will drop in here, and your subclasser won't have to rewrite your repper. Who learned a new technique? Okay, fantastic. And then we use properties and item getter to actually get the failed and attempted. So whenever you take your test result dot failed, it will trigger the property which calls an item getter, which grabs something from position 0, and it'll give you a nice doc string on your tooltip saying failed is an alias for field number 0. So if you were going to write test results on your own to create a name tuple, that's what you'd write. You might add in some extra convenience methods, but this would be the start. Easy enough? How do I make this? There will be a handful of you who cringe at this, and a handful who say, oh, I've learned a new fantastic technique. I contend it's perfectly legitimate. Guido does it. I do it. There's some of you who think it's morally wrong. You know what? I'm going to make another name tuple, and it's going to have exactly this layout. Those of you who come from the web world, doing a lot of Django, Jinja, that sort of thing, you would say, you know what? I can take this thing and make a template out of it, and we can just drop in words like failed and attempted. That, in fact, is the way a name tuple works. It's a factory function that takes a template that looks like this and drops in the words test results failed and attempted and creates a new class. One of the things that's fantastic about this technique is it's self-documenting. You can take a never get questions about how a name tuple works. The reason is there's an option on the factory function called verbose, and it prints this out to the screen. And so everyone who knows their basic Python can see this code, and it answers questions right away, like how does the repper work? Works just like this. Is the repr subclassable? Yes. What would happen if I want to override failed? Well, if someone had typed this class, you overwrite it, put in a new one. No problem. It answers all questions. It is not opaque like C code. It's a fantastic thing. So I fill in the template and run it through eval. What's the problem with running untrusted code through eval? Security risk. You've given access to your whole system to somebody who's possibly defined a field name externally, and they load it in. So we sanitize the results first, just to make sure that they are all valid Python identifiers and there's nothing else magical inside. Okay, convenience methods, building it out. I have this theory in API design. Anything that you make that has some notion of two things associated together where one looks up the other is at its heart a key value pair. And anything that is at its heart a key value pair should be readily convertible into and out of dictionaries. So failed is associated with 0, attempted is associated with 7. Conceptually, that's a dictionary, and someone might want a dictionary. So I provide a under ESDIC method. And then there's a replace. Replace is a fantastic method. It took a lot of design iterations to get to our current version of replace, but it is truly wonderful. What replace does is takes the old result, copies it, replacing one of the fields. So I can say, take the failed 0 and attempted 7 and replace failed with 2, and it makes a new test result. Now, the word replace suggests that it, in place, goes in and mutates the tuple. What's one of the properties of tuples? They're immutable. So it would seem like replace is a bad name. Who knows why I chose replace as the name for this? That's exactly it. We've already got one, and it's very nice. So string replace, strings are immutable, but we do replace, and people seem to get it. And because they seem to get it, and I've already acquired that knowledge, one of the API design principles here was we modeled off of something that you already know, so that the learning curve drops to 0. So if you don't have replace, the old-fashioned way with tuples is the way to make a new one is I create a tuple of length 1, and then I add in result at 1, which is clear about what it does, this line or this line. It's the second one. This is particularly important when we get into a long tuple. And remember, this is special because it can also replace multiple fields at once. So if I had a very long tuple of 50 fields, I could say, go and replace the last name, the first name, update the timestamp, update the quantity available, leaving all other fields the same. Yes, sir? Raises a question, why the underscore and the method names? Who knows? Right. So I have made it to where you can define your own fields, words like failed and attempted. My problem is, if I make a method replace or ESDIC, potentially I am conflicting with one of your names. So we're having a namespace clash. So I've made a deal with you. I said you can use any name you want, as long as it's a valid Python identifier. It has to be a valid Python identifier so that you can say t.failed or t.attempted. So it's a basic restriction. But in addition, I preclude you from using something that starts from an underscore, because those are mine. Fair enough? Would I do this again? No. I made a mistake. I'll take all the blame, but I have to share it with, I reviewed it with everybody on Python Dev. Part of the design of name tuples, we put them out on the ASP.NET Cookbook, and I had comments from dozens of people. So I've deployed this code, got lots of people to exercise it, and nobody suggested until weeks ago, what is our usual way to deal with namespace conflicts in Python? How does the operator module add the word is? Because is a keyword. It says is followed by an underscore. Trailing underscore would have been the correct convention, because our convention for leading underscores is it communicates that this is a private method. So it was a mistake. If I had it to do over again, that would be a trailing underscore. Fair enough? That being said, it doesn't seem to have created a usability problem at all. People seem happy with it, and we've got good results. So I could say we're done with name tuples. You know how to build them, the design principles that went behind making it, what the convenience methods are, and what they're useful for. Would you guys like to put the pedal to the metal and take it for a ride around the block? Just open it up on a track and see what it can do? All right. Pro tip number 1, using the field structure. So remember, it's introspectable. So we had a test result and test results fields is in under other fields. What if I want to make a new result called a labeled result? I take test result fields and then add a new field name onto it and build a new one, labeled results. That way I can chain these together so that I have a name tuple for color, which includes a red, green, blue component or hue, saturation value, however you store your colors. And then I can have another name tuple for a 2D position that has X and Y. I can, from the 2D position, add on to its fields a Z coordinate so that I have a 3D position that includes the 2D. And then I can compose those two and make a colored point, something it has for every point in space. So we can compose these. Who learned a new technique? Very few of you. Amazing. All right, pro tip number 2. This is cool. I get requests all the time. You know what? These name tuples are great, but I'd like to have default values for the fields. Can I do that? Well, in fact, you can if you know this technique. It's borrowed from Prototype OO, the idea that you don't create new objects, you just clone old ones and then modify them. So let us make a prototype instance of a cell. And the prototype instance of cell has color equal to red, size equal to 10, and border equal to false. Look how more self-explanatory this is than a regular tuple where we would have said red, comma, 10, comma, false. A lot more meaning in this. So now I've got my prototype. How do I make new ones with those default values? I just use replace. So let's take the prototype and replace the size with 20. Now I've created an intro that has size 20, color red, and border false. Or I create my lead. Well, my lead is just like the prototype, but its color now is blue and border is false. Now, I don't have to use just a single prototype. I can nest these, and so the lead could be a modified version of the intro. I can have different defaults for different sections and work away. And who thinks this is useful? It's fantastically useful, and it's extremely readable. It beats the snot out of doing this with regular tuples. If you start doing something like this and say t at 0 plus the tuple of length 1, 20, plus t at 2, you've communicated nothing to your reader. Still, this has got to be expensive. Oh, wait. How much overhead does it have? 0. What's a new pro tip? You can subclass name tuples. So you saw that it was just a simple class definition. So since it's a simple class definition, there's no reason we can't subclass it. When you subclass it, if you would like to retain the space efficiency, you ought to also set slots to an empty tuple because that's the way we prevent the formation of instance dictionaries, because slots is not something that inherits. I can add a property, and I can add a stir. A stir is a custom way to print this, the XY point, and hypot is a computed field. Oh, this is fantastic. It reminds us of the database world. I have a database that stores X and Y, but I can create a view that includes a third field, the hypotenuse, as if that value had been stored. So now whenever someone says their p.hypot, it will compute on the fly from X and Y the hypotenuse as if it had been stored. So your name tuple only takes up the space of a 2 tuple, not the space of a 3 tuple. Computed fields is one good use. Another good use is to customize the printout. In this case, I want it to be nicely formatted so that I can produce a table where everything can be read vertically in a nice columnar format. So if I loop over these 2 points, it prints out X, Y, and hypot as if all 3 had been stored and they're all neatly formatted. We learned a new technique. Subclassing name tuples is not exotic. It is very normal. It is a preferred way to use them. Start with what I gave you, the ability to convert it to a dictionary, nice repr, all the little nice features, and then customize it. Change the way it prints, add on new methods. It's the normal way to use name tuples. All right. Did I show you something bad? Okay. I'm actually just going to opine and pontificate for a moment. So all the rest of this, I'm giving you the straight facts, but now I'm going to stand on my soapbox and have an opinion. So you come to Python from some language, statically compiled language, where enum types are important in that language. And they're also cost-free because the compiler compiles them away. So your immediate aspiration, because you aspire to program Java and Python, or JavaScript in Python, yada, 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 your immediate aspiration is, I'm going to make myself an enum type. And it turns out they're more fun to make enum recipes than it is to actually use them, because they're slow in Python. We already have ways to do it, attach things inside a class or in a module namespace. Well, if you were going to do it, which I don't think you should, you could do it with a name tuple. So we can make a name tuple called color. It has fields red, orange, green, blue, and indigo. And I can go ahead and instantiate that and assign a value to each one of these. So now we have color red is 0, color green is 3. Presto, an enumerated type. Who learned something new? Who also learned that they shouldn't do it? All right. Python does not need enumerated types. That is a feature that is vital to statically compiled languages and almost entirely unnecessary in Python. I say almost because there are some use cases where people have a lot of sets of constants floating around, and occasionally you might want to create yourself something that resembles some type of enumerated lookup. But remember, every time you do a dot in Python, you're paying a price. A lot of stuff goes on. This is an operator, just like brackets. It's more expensive than just a dictionary lookup. Oh, you're going to pay the price if you want to say color.red. Why not just use color_red, make it a module variable? Don't pay the price. Okay. Caching. This is a very simple cache recipe. This is not Python 101. It is Python 102, day 1. So after people learn sets and dictionaries and strings and all of our native objects, we teach them a way to make a cache. So we supply a default argument, cache. I could have called this underscore cache to hint that it's private, because this function is not meant to be called with cache as an argument. It's meant to be called with some arguments. And its first step is to take these arguments and check to see if that arg tuple is in the cache dictionary. If it is, it just returns that value. Otherwise, it'll go ahead and do the result of some large computation, one that is time consuming or otherwise resource intensive, take the result, and instead of just returning it, it'll store it in the cache. This is a fantastic recipe. It is Python 102. It is my hope that everyone in this room already knew how to do that. So, who learned something new? All right. What's the problem with this technique? This is a widely used technique. You will see it in many, many code bases. You might have even seen it in the Python core till I got to it. Replace this with something better. The problem is, for long-running processes, this could grow without bound. The dictionary gets bigger and bigger and bigger, and it never frees. Bad. So you run in Django, you put in one little function, cache like this. Every day it gets hit one time, add something to the dictionary, and your long-running process one day falls over dead because it's eaten up all memory for cache that you don't care about anymore. What do we do about it? We have to have some strategy for pulling things out, and a popular strategy is called the LRU cache, least recently used. I will set a bound that says I'll put no more than 100 items in the cache. Whenever there's 100 there, I will take the least recently used, the one that matters to me the least, toss it out and put the new one in. We provide it in the standard library as a decorator. So you take your big computation code and add @LRU cache just beforehand. Presto, you have a cached function that doesn't grow without bound, and you had to add one line to your program, an explicit line that says this particular function or method is cached to a maximum size of 100. Who thinks that's a fantastic tool to have in your toolbox? Unfortunately, it comes in later versions of Python, and I understand some of you are running earlier versions of Python. So what are you going to do? You're going to go to the newer docs, let's say the Python 3.2 docs, and look in Func Tools, see how it works. After having read the docs, you will click on the link, and it will take you to a recipe for a version of this that runs just fine on Python 2.5, Python 2.6. You will copy that into your utils directory, and then you too can write that one line. Fair enough? We learned something new. All right. I could tell you how it was implemented, but it's so darn easy. I used ordered dictionary. Once you've got an ordered dictionary, it takes very few lines to change this recipe into that. Easy enough. Oh wait, some of you are on versions of Python that don't even have an ordered dictionary. What are you going to do? You're going to go to the docs for collections, look at ordered dictionary, see how it works. It's only like 2 paragraphs long. It's very easy to learn. Then you're going to click on the link, and it will take you to the code for an ordered dictionary that runs an old version of Python. So now you've got an ordered dictionary and an LRU cache. Okay. So that's how you implement it. What do we do next? Let's push it to the outer limits. Let's see if we can shoot this thing into stratosphere. Let's see if we can do something cool with it. Because you can already imagine that big computation is you're going out and hitting your database over and over again for the same lookups. So the big computation here is actually saving load on your database by caching the 100 most hit. It could be something that's going up and looking at URLs on the net. So simply by adding that one line, you reduce your amount of net traffic. You no longer have to worry about latency and get a nice performance speed up. Those are the obvious uses. Who knows the origin of the term dynamic programming? Back in the big one, WW2, there was a group of people who were devoting themselves to trying to find more efficient ways to allocate resources. And whenever they used the word optimization or talked about mathematics, the generals that they reported to, their eyes glazed over and refused to fund the project. It seemed like somebody was just drawing symbols on the board and not actually contributing to the war effort. So the head of that project invented the term dynamic programming. It's something that actually sounded like it was closer to we're moving boxes around or we're loading a truck or something that sounded much more warlike. And that is the origin of the term dynamic programming. It is no more significant than that. So this is an example of a catastrophically bad function that has some virtues. So the Fibonacci function recurses twice for each call to it. And then it goes back and recurses again. So if you were to enter this with Fibonacci 100, it would not finish in your lifetime or the lifetime of the universe. It takes a long time to run because it's doing a lot of recursive calls, doing the same lookups over and over again. What is the advantage of writing Fibonacci like this? Because there's a lot of ways to write it. One of the advantages is it corresponds exactly to the way we first teach people what a Fibonacci function is. Once again, you're detecting a theme here. The English problem statement and the code look the same. So I don't want to rewrite this with an alternative Fibonacci. Not that it's a particularly important function, but you get the gist. I want to write my function the way I want to write it for a reason, but I'd like it to be fast. So I add at LRU cache as a decorator before, and now it memorizes the previous calls. If you're out on an interview, it's very common to give people programming tests now. And to check to see if you are a whippersnapper, it's like programming genius, they'll check to see if you know dynamic programming. How are you going to answer the question? You could go in and build up these little internal lists and do things to build stacks that shrink and grow, which is the answer they're expecting because it shows off your amazing programming skill. What I like to do when I get those tests, and amazingly I get them even for consulting assignments. We know who you are, we're hiring you as a consultant, but we're going to see if you can write a Fibonacci function and do it in a dynamic programming style. It comes up, so I like to give them code that looks like this, and I put LRU cache in front of it, and they have a hard time convincing themselves that it works. So we have a tool for that. What is it? Control-Shift plus. Emo bigger. At fib. All right. There's our Fibonacci function. Let's check it. Python 3.2-m. Who knows about the -m option that goes up and looks up modules, like finds the trace module, which we ask it for coverage of fib.py. And cover is not the magic word, is it? It's count. Going off the screen. Yep. Yeah, I see the 2 dots. I just can't see where the 2 dots are, so I'm going to shrink the screen. Okay. Good. All right, that happens to be the answer to the Fibonacci call of Fabo 100. So you can get some idea why there was a lot of computation there. But it created a new file for me called fibo.cover. Who's ever used this before? It's pretty easy to use, which is why I wanted to show it off here. It gives my program back to me, but it prefixes it with the count of the number of times each function was called. So it tells me that because of the LRU cache, I only had 101 calls here. It thinks it's fantastic, because the number without the LRU cache is a little bigger. All right. Who learned a new technique? Good. Yes, sir. Where does count come from? Or how does it get the counts? Oh, no. It's been in for a long time. Trace has been around for a good while. Trace support goes back, Chris, what, Python 2? A long time. Maybe before even. Trace support's been there forever. Armin might know. All right. So, who's very impressed with LRU caches? Think they can do something new and Jedi-like with it? All right. So it has good everyday uses, solves dynamic programming problems, and you've learned to use Trace to produce coverage reports for your programming. So one of our newer gizmos is not in collections. It's the new string formatting syntax. And if you have been to my API design class, you know why it's important that we had it. You know all of the things that were wrong with the % formatting style. So I wanted to show you the new formatting, because how many of you have adopted this as your new preferred style? Surprising number of you. Still, that leaves about 80% of the audience who hasn't touched it yet. So I have a feeling that if I show it to you, walk you through those first steps, you will now adopt it as your primary tool. So I can pass in positional arguments 10 and 20, and by using curly brackets, reference them. So 0 and 1, we'll pull out the tuple at position 0, the argument at position 1. Easy enough, just like the positional arguments with the % formatting you're used to, but without %s's. Instead, it's just curly brackets. Already it looks slightly cleaner. Now we look down and pass in keyword arguments, which is nice because I can look them up by name. Page, curly brackets page, curly brackets line. Isn't that beautiful? That is way better looking than % formatting. And one of the nice things about it is % formatting is just complicated enough to where you only show it to programmers. No one ever exposes that to the end user for templates. This is simple enough to where you can show end users templates like that so they can format their own pages. So if you're an author of a Django app, you might want this. The users can customize the look of their page. I think it's beautiful. But those are powers we already have. Do we get anything new? Matter of fact, yes. We get indexing and attribute lookup. I'm going to create an empty person class, assign an attribute there, last name. There's lots of ways to do this. We could have made name tuples. We could have very rich objects. The important thing is there's some attribute we can look up. I can now reference that. In my curly brackets, I put p.lastname. That's kind of neat, especially if you have a longer string where you pass in one p, single argument, but have multiple references to it inside. P.first name, P.last name, P.title, P.age, P.department. All those things you pass in one argument, but use it many times. Who thinks that's fantastic? All right. Now you can also use tuple style access, so you can give me the thing at position 0 and position 1. But we don't do that anymore because we use name tuples. All right. It probably does not surprise you that we can do a little formatting control in this. So I can put a colon after it and provide some specifications of how this should print out. So if I put :8, it will pad this to 8 characters. If you look at the shape of these 3 symbols up here, one is left angle bracket, one is a caret, one's a right angle bracket. Essentially, they're like arrows pointing in a different direction. That's the way to remember that the left angle bracket says push to the left side, the hat says go to the middle, and the right angle bracket, or the default, pushes to the right. Easy enough so you can control the alignment. No more L-just, R-just, and center. You actually specify the format in the correct place, not in the code, but in the template. And the template is really concerned about layout. So you move layout information in the template where it belongs. I believe that's an improvement. And then you can also prefix this with some character to say what the fill character is. So instead of padding with spaces, you can pad with number signs or whatnot. I think that's kind of cool. All right. Now, some of this is not terribly surprising to those of you familiar with the details of the percent formatting. You know, this has it too. So we want to format pi. I tell it with leading zeros, taking a total of 8 spaces, out to 2 decimal points, and print the sign regardless whether it's positive or negative. Put a minus there, it'll only show the minus if it's negative. Straightforward stuff. Next one's kind of new and special though. Something just happened. Something new you haven't seen before. I wrote a PEP on this. There's a comma. Now I have 1,000 separator. What about people in Europe? I tried to sell Quito on all types of ways to indicate what the 1,000 separator should be. Problem is 1,000 separator changes, and then the decimal point changes, and then there are different grouping conventions. I learned there's some countries where the 1,000 separators really 10,000 separators or 100,000 separators. There are ISO standard for grouping of at to the right of the decimal point in groups of 5. Quito decided, let's do the simplest thing that can possibly work. Make this so that people can remember how to insert it in, so there's just one control character, so that all the things that implement their own formatters only have to understand one control character, and then we will leave it up to users to use .replace. Now, how do you replace the commas with the periods here? Well, it's the three-way dance. And the three-way dance says, in order to exchange the two things in my hands, I need... The exchange here is I put in a temporary location, I move this one to this one, I pull this back up. Fair enough? So, I would replace the period with something like an exclamation point. Replace the commas with a period. Replace the exclamation point, comma. Kind of a nuisance. Would you want to do that over and over again? No. You make a function called Frenchify it, Germanify it, Africanize it, Asianify it. With me? Okay. That was Quito's recommended solution to the problem, and it has the virtue of at least being simple. Questions, suggestions, comments, or complaints? Yes, sir. I had many proposals. Quito approved one. There were lots of ways to skin this cat. The problem is, if you look at the description of how we write these strings, of all the possibilities, it's already reached a complexity limit that says any addition to it actually makes it worse rather than better. Even though we add a new capability, the ease of use matters more than the extra capability. It's Python day one to be able to fix this thing. But there's another way. You could use a locale module where there's already support for this. And if you're in one of my classes, other classes, you know how to handle the fact that locale is global setting. And so there's some issues there that need to be resolved. But locale will take care of this for you. So I think we are at the question period. Yeah. All right.
So can you go to the end of a counter? Okay, when there is the subtract, previous slide. Previous slide. Oh.
These are previous slides. I'm going backwards.
Or wait. So whether there is a subtract.
Where there is a subtract of counter?
Yes.
A subtraction. Okay, so this is, there are two subtraction slides.
Yeah, exactly.
This one? Yes.
So I was a little confused since in the upper part you say subtract d, that's difference 2 counter, and then in the example you show that you take named arguments with the subtract method.
Okay. So the subtract method will accept named arguments. It will also accept another counter. So I have spared you from going and creating another counter, because the way named arguments work are they create a dictionary. What is a counter? It's just a dictionary. So there was no sense in, once somebody provided A equal 1 and C equal 1, there was no sense in then wrapping a counter around it before I go on. So I could have put the word counter here, right there, to create an internal counter to subtract the two, but I can also do it directly by keyword arguments. It was just a simpler API. Either would work. Does that answer the question or no?
Yeah, actually, now I see the difference between this problem and the problem of positional arguments of the other
Yes,
code.
okay, they are two different problems.
That was confusing me because it was looking similar at the first sight.
Fair enough. Anything else? Yes, sir. Okay, so we discussed before the reason for the instead of regular instantiation, I could have done that. What make is for is, you learned in my API class earlier this week, that whenever there's a need for two different types of constructors, one with positional arguments and another with iterable, the correct answer is always to provide both. So the default for a named tuple is you'd be able to take color and say color open paren 1, 2, 3, whatever, separate fields. But if you already have a tuple made, in this case range has an input that is already an iterable, the way I pass that in is with make. So it's just an alternate for. So I could have here eliminated the make, put the open brackets and used a star. So it saves you from star unpacking. Make is less useful in this context. Star probably would have been better for this example. Place where make is really useful is if you have a giant list of tuples and you're casting them all to your named tuple, like you've got a query back from a SQL database and you want to name tupleize all of them, you run it through map with make and it converts all of them over, because otherwise you'd have to build a list comprehension, you'd do a star on every one of them, which would unpack it on the stack just to rebuild it back again. It'd be terribly inefficient and that wouldn't be any fun. And Jacob?
Is the new formatting backported to 2.7?
I believe it is. Oh, one other thought on the new formatting. Should you use the new formatting or the old formatting? Yes. All right. So whenever you see a format, somebody presents you with some type of formatting, like out at Bash, we use a $, which raises the question, how do I emit a $? There needs to be some way to escape it, and the answer is $2 is 1. All right. How do I emit a percent with regular percent formatting? I escape it by doing %%, which is a real problem if I'm going to apply the format in multiple successive stages, because then I need %, run it through one level, takes it down to 2, and then leaves 1. What do we do for the new style formatting? How do we escape curly brackets? We double them up, curly bracket, curly bracket. Who hates that? I do. How do you deal with it? The way I deal with it is I use new and the old formatting. All right, so if I have a percent sign inside, so sometimes I want to format a string that actually has formatting inside it. And whenever I need to do that, I do the innermost one with the old style formatting and the other one with the old style. And that way I don't have any escaping. Who thinks that's a wonderful little technique? If you work on it for a while, you take that technique and try and encapsulate it and describe it in a sentence, and then scrunch the sentence, and then make the word smaller, and scrunch it. After a great deal of effort, you can compress it into less than 140 characters, in which case you could share it with the world in a tweet. How could you have found out about this before this class? If you follow my Twitter stream, you'll get tips like this every day, at Raymond H.
And I'm sorry, we should stop here for this talk
Finito?
for now. Yeah. Finito.
Okay. Did you guys have fun? Cool.
Yeah.